All right. Ladies and gentlemen, listen up, please. What we had is, remember we talked about 4 different functions, correct? Tim, do you know one of those functions? No. Darren, do you know one function? Linear is, well, an identity, which we're going to call it, okay? Because identity is one of those functions. Identity was f of x equals x. Chase, you have another one? Constant. That's when your function equals a number, right? And that was going to be a horizontal line. So we have identity, which when f of x equals x, which is like that diagonal line. Then we have a constant function, yes? Absolute value function. An absolute value function is when you have those absolute value, right, brackets in your function. And then the last one, yes, Iago. Quadratic, exactly. And quadratic is when we had a variable raised to what power? To the second power. Very good. So those are the 4 things, all right? Please make sure tonight, if you don't know those, go back home and just look over the graphs and understand them so you can determine them. So here, we notice I have an absolute value of my x. So therefore, I'm going to be dealing with an absolute value graph. All right? So how do you graph an absolute value? Well, the first thing you guys need to understand is what an absolute value graph looks like. Remember, absolute value graph was that V graph, right? And it's a V graph when using a table of values that has a slope of up 1 over 1 or left 1 over 1. So it has a 1-to-1 relationship. All right? It's this V. So when you guys are graphing, the main important thing I'm going to want you guys to do is always graph the parent function. When you have to graph, always graph what the parent function looks like. All right? Now you guys should know the table of values for this is the absolute value of x. So if I did -2, -1, 0, 1, and 2, the absolute value of -2 is 2. Absolute value of 1 is 1. 0, 1, and 2. Okay? Now, the next thing we need to do when graphing absolute value, yes?
How is that all?
Because remember, the absolute value means the absolute distance from 0. So think of a number line. Even though I'm going -2 to the left, what is the distance from 0? 2. That's why think of absolute value as always absolute distance from 0. Yes? It will, but that would be an equation, not a function. Right now we're just talking about functions. But that would it look like that if instead of if these were switched, if it was the absolute value of f of x equals x. Okay? Right, if those were switched around. All right. So how do I graph this? The next thing is I need to determine what are my transformations. So I'm having an adding and subtracting. Am I adding or subtracting inside the function or outside the function, Trevor? Exactly. So I'm looking at, I'm adding, or I'm subtracting a 3 outside of the function, right? What would it look like inside the function?
It would be x minus 3.
You guys have to understand that difference, Trevor. Inside, outside. When you're subtracting a -3 outside of the function, that shifts your graph up or down. Since it's negative, I'm going to shift my graph how many units down? 3. So I go down 1, 2, 3. And guess what I do? I just redraw the graph. Since my graph goes up 1 over 1, I do the same thing. So there is my graph. That's the parent graph. That's my next graph. Does that make sense?
For inside, you go left.
Yes.
If it was positive 3, would you go up or?
Yep. If it was positive 3 outside, I'd go up. Yes. If it was inside, if it looked like this, then you'd shift the graph to the right. And if it was positive, you'd shift the graph to the left. Okay? Yes, the opposite value. Okay? Okay.